This video is looking at the final part of the energy module for the first physics exam at GCSE, and it covers energy resources both on a global level and on a national level. So this topic nearly always comes up on the exam, and most commonly it is used as a way of trying to assess how well you can analyse data and look at trends and patterns in data and talk about them. So whilst I'm going to cover some basics about each of the various types of renewable and non-renewable energy resources, it isn't explaining how each of them works in detail that is the focus of this. It is invariably on the data analysis. So we need to know what the different energy sources are, the difference between renewable and non-renewable, and be able to describe and discuss advantages and disadvantages for each. So I take a moment just to read through what the specification requires you to do and not to do in relation to this section. Okay, some basic keywords first. So when we talk about energy resources, we're talking about any physical method or fuel which is used to generate electricity or to produce electricity. So this is in contrast, say, to energy stores, which we think of as different forms in which energy might be sort of manifest in terms of like joules. So you can have like electrostatic store, kinetic store, gravitational store. When we're talking about energy resources, we're talking about ways of generating electricity. So we're thinking about power stations basically, so like coal, oil, natural gas, but also not renewable versions like wind, solar, hydroelectric, etc. So renewable energy resources are ones that are not going to run out on a timescale of millions of years and can be replenished. And that's the key language that is used and referenced in the specification from AQA. It's that idea that they can be replenished. We can, biomass, for example, is renewable because we can plant new crops within our lifetime and we can harvest those crops and continue to burn them. We're not going to run out of wind, for example. The sun will continue to exist for a very long time, so in our lifetimes that's renewable. Obviously non-renewable are ones that will eventually run out because we have a finite amount and they can't be replenished in our lifetime. So it takes millions of years to form fossil fuels, for example, such as coal, oil and natural gas, and also nuclear fuels such as uranium. So these are our non-renewables, and we'll go through those in a moment. Obviously I've just mentioned fossil fuels specifically, so those are chemical fuels produced over millions of years under the effects of heat and pressure from either the remnants of wood or of sea creatures, and as they're compressed within the Earth's crust, they eventually are turned into coal, oil and gas, etc. So because they come from fossils, they take millions of years to produce. Okay, so in terms of energy resources, as we said, there is a whole range, but ultimately we use them for three primary things. We use them for heating, we use them for transportation, and we use them for generating electricity. In the UK, we have a direction of travel where we are trying to become more responsible and we can continue to reduce our proportion of non-renewable resources, increase our number of renewables in an effort to become carbon neutral. So obviously transportation covers things like petrol, diesel, both for cars, lorries, but also for shipping containers and for trains and for aircraft. Obviously there are energy methods of travel that don't depend on those things, like for example cycling, but that's one sort of area where we use our energy resources. Obviously we can use things like solar power to generate electricity. We can also use like gas for heating in our homes and for cooking and things like that. So this is one example of a type of data that you might get given in the exam for this section. So this shows in 2015 the proportion of the different types of method or energy resources in the UK for generating electricity. So you can see here that at this particular point in time there was about just under a quarter of fuels were renewable, and the largest source here we have in the UK at this point was gas. Coal was 22%, nuclear was 21%, and obviously you might get another data set where you're asked to kind of compare and contrast it to the data at this time and talk about how it's changed. So always focus on kind of the extremes. Think about which one's biggest, which one's smallest. Think about any sort of general anomalies that you can spot when you're kind of describing that type of data. So it's important to understand how a conventional power station works, because this applies to pretty much all the methods we talk about. So a conventional power station, we're going to start off with one that is burning fossil fuel, has 4 key stages. So the first is the fossil fuel has to be burnt, and that's to produce heat energy, which then is ultimately going to pass through the boiler, which is step 1. That boiler obviously produces steam, and it's that steam that's then going to turn the turbine, which is connected to the generator, which consists of magnets which rotate inside large coils, and that generates AC electricity. That's covered in more detail in triple science specifically. And then we have the transformers, which are used to transmit electricity efficiently from the power station to your home via the national grid. So you should understand about step up and step down transformers and how they work as kind of part of that process that comes later in the course. So the summary of the stages: you have the boiler, turbines, generator, transformer, and then the national grid. Okay, and we should be able to describe each of those. Just a quick note on nuclear power stations. Nuclear power stations basically work exactly the same way apart from step 1. So instead of it being a chemical reaction, like burning combustion with coal, oil, or natural gas, we use a nuclear fuel, either uranium-235 or plutonium-239, and we undergo a nuclear reaction, specifically fission, to generate that heat. But the rest of the process is exactly the same. So we still use that heat to boil water, to produce steam, to turn the turbine, to turn the generator, then go to a transformer and the national grid. It's just the method of generating the heat which is different. So if we kind of summarize our non-renewables, then we can say we've basically got 2 types. We've got fossil fuels and we've got nuclear fuels. So the 3 fossil fuels you should be aware of are coal, oil, and natural gas, and our nuclear fuels are uranium and plutonium. The advantages of fossil fuels are that they are very reliable. So they're not dependent on the weather. They are have fast startup times. We can just, if we want more electricity, we just burn more coal. Historically, they've been very cheap and geographically available, and they're reasonably easy to transport. Nuclear fuels, the advantage of those is they have a particularly high energy output, and unlike fossil fuels, as we'll see, one of their big disadvantages is they produce carbon dioxide. Nuclear fuels do not, and we don't need to use very much fuel to get out a large amount of energy. Now this is where the disadvantages come in. So fossil fuels, the biggest single disadvantage is the release of CO2, which contributes to the greenhouse effect and global warming. You also get impurities such as sulfur, which produce things like sulfur dioxide, which cause acid rain in fuels like oil, coal and oil. Mining in itself can obviously be very damaging to the environment. It can be noise and visual pollution. Oil spillages are a serious problem, and it's becoming more and more expensive as time goes on. Nuclear fuels, the big disadvantage of those is the risks associated with, first, there is nuclear waste in fission reactions, which needs to be carefully managed, and if it isn't managed, then there is a risk of contamination, particularly if it gets into the water supply. There is the risk of kind of nuclear disasters, and nuclear reactors can't be turned off and on quickly. They have very slow startup times, so they're very good for maintaining a high energy output over time, but not good for kind of peaks in demand. So if you look at our renewables, which will not run out, we've got most of them come from alternative sources of energy. Only one is a fuel. So we have, in terms of our sources of energy, solar power, wind power, tidal, wave, hydroelectric, and geothermal. Our fuel is biomass. Now, if you think about the energy store that's involved in each of these, obviously solar power gets its energy source from light. Wind, tidal, and wave are all kinetic energies directly. So obviously the wind itself, the air as it moves, it carries its own kinetic energy that can be transferred directly to the turbines of the wind power. Obviously tidal and wave, it's the kinetic energy of the water. Hydroelectric, at the point where the turbine rotates, it is the kinetic energy of the water that turns it. But the thing that generates that kinetic energy in the case of hydroelectric is the water falling from a higher gravitational potential to a lower, and so it's gravitational potential, which is like the initial store. Geothermal is obviously thermal, so directly from the Earth's ground, in the ground, and biofuel is chemical potential, like our fossil fuels were. Remember, our nuclear fuels come from nuclear potential. So you can see there clearly the difference between the energy stores and the energy resources that utilize them. If we talk about general advantages and disadvantages of each of these, so the big ones is that the majority of them, with the exception of biomass, don't release CO2 or sulfur dioxide, so they don't cause global warming or acid rain. They typically have much lower running costs, and very obviously renewable is an advantage itself, and some of them have very fast startup times, like hydroelectric. The disadvantages, however, are the fact that they're very often expensive when we initially set them up, and some of them are unreliable in terms of their energy output, particularly when they're responsible for like weather. So, for example, solar power only works when there is a lot of sunshine, and wind only works when there is a reasonable and consistent sort of breeze. There is pollution and environmental damage caused during their construction, and some people will complain of noise and visual pollution. Some of them are limited by geography, so for example you cannot put a geothermal power station anywhere, and biofuels, as we said, are still a fuel, so they will still produce CO2. So biomass just specifically comes from living material, so it can be made from farm waste, animal droppings, landfill rubbish, or grown from crops such as sugarcane. So it has a wide range of sources, but the important thing is all of these things are replenishable. When we obviously burn biofuel, we burn it in much the same way we would for fossil fuels. It's just that obviously it can be replaced. What we try to do is we try to make sure we produce the biofuels, which as we burn them, obviously that produces and releases CO2, but obviously whilst the crops are growing, that is also taking CO2 from the atmosphere. So we often regard these as better than fossil fuels because we consider them to be carbon neutral. So it sort of is like cancelling itself out during its life, effectively. They have a lot of advantages that we've already mentioned, but one disadvantage specific to this, just to be aware of, is obviously it is an artificial habitat, and so therefore it leads to a reduction in biodiversity, which can sometimes be a little bit of a problem. Very quickly, so wind power, obviously this has the turbine directly exposed to the air, and obviously the kinetic energy from the air is transferred to that which turns the generator and produces electricity. You may just want to pause on the advantages and disadvantages of each of these as they come up, because I'm not going to spend that long on them. The main thing here is the unreliability. And again, you're not going to be tested explicitly on all the detail of how it works. The main thing is you understand some of these advantages and disadvantages. Solar power, sometimes known as photovoltaic cells, again, are used when light energy is converted directly to electricity. Obviously, one advantage of these, that just to point out, is these work well in remote locations, and also you can improve efficiency if you're using the thermal energy from the sun, the light energy from the sun, not only for generating electricity but also for heating. So we have this idea of passive solar heating, which is also useful. Hydroelectric, as we've mentioned, the big additional disadvantage I want to mention here is loss of habitat. So obviously in order to produce a dam you have to flood a large area, and that can cause loss of habitat and obviously death of some species, so we have to be really mindful of that, and it's very, very expensive when we initially set it up. Tidal barrages can be used at key points in the UK. This is the Thames barrage, and this works basically as that the water flows in and out up the stream, the river. Obviously that turns turbines and can then generate electricity. It also can act as a method of flood defence, which is an additional advantage. It does affect the habitat similar to hydroelectric and is variable depending upon the tide. Geothermal, again, the key thing here is geographical restrictions, okay, and the water is generally pumped into the ground and comes back up as steam. So, as I said, what you're really going to get tested on in your exam is data about this. So, I've already shown you the pie chart earlier on, which is one type of data you frequently get. Here is another where you get data sort of over time of how these increase or decrease. In this case, this is about the world. Now, one thing just to note is very often what they will do in exams is juxtapose energy for the UK and for the rest of the world. The key thing to know is that even though, for example, in the UK we might be increasing the number of renewables, globally that's not necessarily the case because of these three factors. There is a huge population increase, so we're now over 7 billion people. Obviously, each of those people then wants more electricity, more devices, more transportation, and more electricity. So there's three things we're looking for: transportation, heating, electricity, all increase as the population increases. And that's what drives global factors more than anything else. So whilst in the UK we might try to become and compensate and become carbon neutral, there is this challenge that the rest of the world are not necessarily doing that. So when you're describing this type of data, look for your basic trends, look for the key things that are increasing and decreasing, look for your extremities, what's the highest, what's the lowest, and try to pick out anomalies, and you won't go too far wrong.